Following on from the previous two videos, I gave you a function f of x equals x squared, and then when we looked at this function here, when we try and graph it, it looks like a quadratic like this, and then we investigated this f of x, whatever the old function was, then you would add 3 to it, and then it gives the effect that you're pushing up everything by 3. Well, the thing is, it doesn't have to be a quadratic. It can be any function. Suppose you have a graph like this. Suppose you have a function looking like this. Okay. If it doesn't matter what function. Let's say this is f of x here. Now, when you want to investigate f of x plus 3, f of x plus 3 here, it would be, well, whatever the old value was, this one here, and then you would add 3, so you shift it up by 3, so the new value would be here. Suppose this point here, you would, well, if f of x, at this point here, for f of x is here, but if you want to find out f of x plus 3, then you would work out the old one, which is right here, and then you would add 3, so you would add 3, so you would move it up here, okay, and so on here. Suppose it's here, you would add 3, so as it turns out that it will be the same shaped graph, if you like, but everything gets shifted up by 3. So my point is that it doesn't have to be a quadratic. It can be any function. And then if you have any function here, and then you add 3, then everything gets shifted up by 3. Okay. If you have f of x minus let's say 7 here, it would be whatever the old function was. Let's say this function here, and then it gets dragged down by 7 because of this thing here. So your new graph will be in exact same shape, but it just gets dragged down by 7. Now in this video we are going to look at, well, we've looked at this one here. Okay. Now we are going to look at this one here. Okay. Let me just tidy this up. Oh, before I do, you see, looking at this blue line here is f of x. Don't forget f of x here. F of x here is defined as x squared. Now the red line here represents f of x plus 3. So what that means is f of x. Let's say f of 0 is here. And then when you want to find out what f of x plus 3 is, well, you get the old f of x, and then you add 3. So it's 1, 2, 3. It gets shifted up by 3. Suppose you're here, then again you get shifted up by 3. 1, 2, 3. So your new value would be here. You see, it would be the same shape, but everything would get shifted up by 3. Okay. Hang on. So now we are going to investigate. Now we are going. Well, we've looked at this here. Now we are going to investigate this. How does this compare to this one here? Okay. So let me just clear this up. Okay. So now don't forget f of x here is our quadratic like this. Now we want to investigate what happens when you have f of x plus 2. Okay, so look, hang on, let's just extend this table out here. Bear with me. Okay, so now if f of x is here, now we want to investigate f of x plus 2. Now for our first point here, which is f when x is 0 here, we put the we put the 0 into this x here. So it would be f of 0 plus 2, which is 0 plus 2 is 2, which is in effect us trying to find out f of 2. Okay, so what goes in here will be the equivalent of f of 2. Well, you see this here is really f of 2. This number 4 here is really f of 2 here. So this here would be 4. Okay, well, anyway, if you put 2 into this thing here, it will be 2 squared, which is 4. Now come the 1. We now want to work out what goes in this block here. So we will put the 1 into this x here. So it will be f of 1 plus 2, which is the equivalent of you working out f of 3. Okay, f of 3, put it into here. F of 3 will be 3 squared, which is 9. You see, this one here is also f of 3. Well, you can see that it gets shifted across like this. Well, and anyway, come to work out 2 now. Put the 2 into this x here. So that's the equivalent of you working out f of 4, because 2 plus 2 is 4. You see, when you put this into this thing here, it would be 4 squared, which is 16. You see, this is like this here. Now let's look at minus 2. Suppose you want to look at minus 2 here. This one here is 2, minus 2 here. If you put minus 2 into this x here, it will be minus 2 plus 2, which is the equivalent of you working out f of 0. Well, f of 0 is 0. Well, what goes in here will be 0 here. So it will so the new point will be here. So what's actually happening is this. Hang on. Bear with me. So here the blue line here, the blue line here represents f of x, which is defined as x squared. Okay. Now, if we want to investigate what f of x plus 2, we want to investigate this here. Okay. Let's say at 0 here. Imagine you didn't know this red line here. Okay. Imagine you didn't know that. When f of hang on, we are trying to investigate this f of x plus 2. Now, if you put 0 into this x here, it's the equivalent of you. Well, if you want to work out the first point for this function here, you would put 0 into this x here. So that's the equivalent of you working out f of 2. Well, f of 2. The f of 2 of the old function will be here. Well, basically, what I'm trying to illustrate is that it gets shifted across like this. Okay. If you look at f of let's try and investigate this, but at x equals negative 2. Well, at negative 2, you put the negative 2 into here, and it's equivalent of you working out f of 0. Well, f of 0 is here. And then it gets shifted across like this. So my point is that, hang on, this one here, everything gets shifted across by 2 here. So it was here, and then it gets shifted across by 2. So what I'm trying to illustrate here is that if you have f of x here, and then you want to investigate f of x plus 2 here. Well, when you have plus 2, it gets shifted over by 2. It's a bit hard to. I will give you more examples on this later on. Okay, but it's a bit hard to illustrate to you. But what's actually happening is that it's getting shifted across by 2. Okay.